Okay, let's go over this sample final. Problem number 1. So we need to do the order of operations. So we have parentheses that we have to do inside, and there's subtraction and multiplication. Multiplication happens first, so 2 times 3 is 6. And then we still have parentheses. 10 minus 6 is 4. And now we can drop the parentheses because that's been simplified. But we have powers that come next, so we have to take the 4 and square it. And now we have multiplication, which has to come before addition. So we have 5 plus 3 times 16 is 48. And we finally end up with 53. Okay, number 2. That's a -2, not a negative exponent. The 2 and the 4 reduce to a -1/2. And then we have x to the -2. Minus means we'll change to a plus exponent if we lower it. They want positive exponents. So if we take it down across it, it becomes x to the +2, and we have x to the 3rd down there. And we have y down here, and it's to the 1, so 1 from 3, or this is y times y times y. One of these y's cancel. Or when you divide, you subtract exponents. 1 from 3 is y to the 2. So we have -y squared over 2x to the 5th. When you multiply, you add the powers. Scientific notation. So we've got to go 5.2. The decimal has to be just after the first non-zero digit, which is the 5. So this number is bigger than this one. So to get it back to that size, I have to multiply by 10, actually divide by 10, so it's a negative exponent. I have to divide by 10 one time and get it to here, and then I got to move it 2 more times to make it there. So that's 3 times. Now we got to simplify. This is square root, so we're looking for pairs. 5 and 8 is 2 times 2 times 2. And x, 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 x. 1, 2, 3, 4, 5, 6 of them. Square root. So there's a pair of 2's, comes out as a 2. So 2 times 5 is 10. A pair of x's, a pair of x's, and a pair of x's. That's 3 of them, so that's x to the 3rd. Square root. I don't need to put a 2 in for the square root. There's 1, 2 that we weren't able to take out. Now, the degree, that's the highest exponent, so it's 4. Leading coefficient is how many x to the 4th we have. -3. Most powerful near 0. This is the most powerful far from 0. The lowest power of x is most powerful near 0. So that's 5x squared, the term with the lowest degree. And far from 0 is the term with the highest degree. Page 2. So we're supposed to simplify this. 3x times 5 is 15x x. 3x times a negative 2x. 3 times 2 is 6. It's negative, and x times x is x squared. There's nothing to distribute, so I can drop these parentheses. So the highest power is x to the third. That's negative x to the third. Next highest is squares. We got minus 6x squareds plus 7 of them. So that makes plus 1x squared. And then we have some x's, 15 of them plus 1 of them. 16 x's, and there's no just constant. So that's it. Multiply these and sketch the model for it. What's 2 x's? So random length x, and another length just like it, x. So there's 2 x's plus 1. I'm going to make 1 be that long. And then I got x in the other direction. I'm making it the same length as that one and as that one. And plus 3, and I made 1 that long, so I got to make 1 be that long when I go in this direction. And if I finish my rectangle, draw some lines in here. This was x, and this is 3. 1 times 1 times 1, and this was 1. 2x plus 1 more. X times x, and x times x. So I get 2x squareds. Now this is 1 times x, and 1 times x, and 1 times, so this makes 3 x's. So does this. And this makes x times 1x. So I have 3, 6, 7 x's. And then I have 3 times 1, which is 3. Now it says expand these and combine like terms. So 3x times 2x is 6x squared. 3x times 5 is 15x. Now we got to take that answer. We don't take this times this and this. This times one of them. And then that answer times the other one. So 6x squared times x is 6x to the third. 6x squared times the minus 1 is minus 6x squared. 15x times x, and 15x times a negative 1. So I have, these are like terms, so I can combine them. So I'm going to have a 6x to the third. And here we're going to have plus 9x squared minus 15x. Now this one. So 5x squared times x squared is 5 times 1 is 5. X squared times x squared is x to the fourth. When you multiply, you add the powers. 5x squared times an x is 5x to the third. This has a power of 1 plus 2 is 3. And 3 times 5x squared is 15x squared. So that's 5x squared times each of those. Now I got to take negative 2 times each of those. So it'd be negative 2x squared, negative 2x, and negative 6. And now I combine like terms. I only have these x to the fourths, I have this many x to the thirds. I have 15x squared minus 2x squared, which is 13x squared. And then I have minus 2x minus 6. Next page. Simplify. The first step of simplifying is to pull out things that are in common. See, I think there's an x in both of those, so it would be x times 5x would make 5x squared, and x times a negative 3 would make a negative 3x. Anything in common here? Oh, I think 5 goes into both of those. 5 times 5x makes 25x. And 5 times a negative 3 would make a negative 15. These look the same, and so this reduces to x over 5. We're supposed to graph negative 5, 3, 1, 2, 3. We're supposed to graph negative 3, 0. So that's B. We're supposed to give the coordinates of C, which is 3, 6, in parentheses, of D, which is 5, negative 3, and E, negative 5, 0. And what is the number of the quadrant for D? Well, it's 1, 2, 3, 4, often written Roman numerals. It's the fourth quadrant. Page 4. Graph the line y equals 3x minus 6. So the y-intercept is negative 6. And the slope is 3. So I got to go up 3 for 1. 3 for 1. One, two, three, 1. Etc. Now, I could also do it. If you don't know how to graph using the slope and the intercept, you could use Desmos, or you could also make a table. If I let x be 0, 3 times 0 is 0, minus 6 is negative 6. If I let x be 1, 3 times 1 is 3, minus 6 is minus 3. And 2 times 3 is 6, minus 6 is 0. So it should go through 2, 0, 1, negative 3, and 0, negative 6. And it's a line, so I just keep it going on. Got a little crooked there. Okay. What are the x and y intercepts? Well, the x-intercept is 2, 0. And the y-intercept is 0, negative 6. Graph x equals 7, where all the x's, see the x's tell us how to go sideways, where the x is sideways, all the points were over 7. That would be here. This is 7, 0, 7, 1, 7, 2, 7, 3, 7, 4. And so here is that line. Now we're supposed to solve this one. So 5 times 3 is 15. 5 times negative x is minus 5x equals 5 minus 10x. Getting all the x's on the same side, I could add 10x to both sides of this equation. So I get 15 minus 5x so we get 15 minus, plus, because we added, plus 5x equals 5. Subtract 15, and we get 5x equals negative 10. And x, divide both sides by 5, x equals negative 2. Let's just check ourselves. 3 minus a minus 2 would be 5. 5 times 5 is 25. Negative 10 times negative 2 would be plus 20. Plus 5 is 25. So it checks out. A homeowner is cleaning carpets and needs to rent a carpet cleaner. Super Cleaner rents a cleaner for $20. So the cost is $20 plus $5 per hour for each hour. Another one, the cost at Lovely Clean is, they rent it for $25, so it costs more up front, but it costs less per hour. So it says determine the number of hours when each rental cost is the same. So we want to know when this equals this. So we'll write that. 20 plus 5 times the number of hours equals 25 plus 4 times the number of hours. So if we subtract 4 hours from both sides, and subtract 20 from both sides, we get 1 hour is, and 25 minus 20 is 5. All right, so the hours are 5 hours. After 5 hours, they both end up charging the same. We can check it. 5 times 5 is 25, plus 20 is $45. 4 times 5 is 20, plus 25 is 45. So if h is 5, then this equation, the cost for that one and the cost one would both be $45. Next page. Jorge drives to work averaging 30 miles an hour and returns averaging 35. The total time driving is 1.5 hours. How far is it to work for Jorge? Write an expression for the time it takes to go d miles. So the distance divided by the speed is the time going to work. And returning home, he goes faster, so it's the same distance, but going 35. Do something times this, and that's the time coming home. And it said the total time is supposed to be 1.5 hours. And I could have written 3 halves. But anyway, what's the common denominator? Well, I don't think it's going to be 35 or 70, but I think since 5 goes in this and 7 goes into this, it's probably going to be, what was I going to say? 35, 70, 140. So I'm going to have to multiply this one. See, this is 7 times 5, and this is 6 times 5. So I'm going to have to multiply this one by a 7, and this one by a 6. And so I'm multiplying by 7 times 6 times 5. 6 times 5 is 30 times 7 is 210. So if I multiply by 210, 30 goes into that 7 times. If I multiply by 210, 35 goes in that 6 times. And I multiply this by 210. And so I get 7 at D's plus 6 D's, 13 D's equals 210 plus half of 210, 105, is 315 divided by 13. And the total distance to work for this person is, I don't know that one off the top of my head. I'm looking for a calculator here. $315 divided by 30, 10.5, and this distance is in miles. Solve by factoring, so we want it equal to 0. So I'm going to subtract 8x, and then I'm going to write these in decreasing powers. So I'm going to have 5x squared minus 8x plus 3 equals 0. And you may have a way to solve by factoring by grouping or by grids, or there's a whole bunch of ways. I was teaching the strips because nobody else I know does that. And so we're supposed to line up -8 and 0. And we want to get a pair that multiply to be 3 times 5, 15. 15 is positive, so if I got a -8, I'm going to have to make this side negative. So I'm going to go -1 and -7, still a total of -8, -6 and -2. That multiplies to be positive 12, -5 and -3. That multiplies to be -15. So I get x minus 5 and x minus 3. But I need to have a 5x squared. So I'm going to divide this 5 by 5 and put the 5 here. Remember, they exchange on the inside or they exchange on the outside. So we have x minus 1 and 5x minus 3 multiply to make this. And so if I'm trying to make this be 0, then either the x minus 1 equals 0. And if I add 1 to both sides, I find out x equals 1. That's one solution to that problem. And another would be 5x minus 3 equals 0. So I'd add 3 to both sides and then divide by 5, and I'd get x equal to 3/5. There's the two solutions. Okay. Now, there's lots of other ways to solve this, but I want you to show me how to factor. Okay, now I want you to show me that you know how to use the quadratic formula. And to do that, they have to be in order, equal to 0, so that the a is the number of x squareds. So a equals 2. B is the number of x's. Never carry the x along, so b is just the number of them, -5. And c is the constant, in this case 1. And the quadratic formula, which you should have on your note card if you don't have memorized. So it's the opposite of b, so that'd be a +5, plus or minus, so there's two answers, the +1 and the -1, square root b squared. So -5 times -5 is +25. And -4 times a and a c, which are both positive, is going to stay negative. And -4 times 2 is 8, times 1 is 8. Over 2 times a. 2 times 2 is 4. That's both of these are over 4. Now, if you don't want to draw one line for all of it, you could write 5 over 4. And let's see, 25 minus 8 is 17. Plus or minus the square root of 17 over 4. So there are the two answers. Now, if you want to write them separately, you could go 5 over 4 plus the square root of 17 over 4. That's one answer. The other one is 5 over 4 minus the square root of 17 over 4. Next page. Interval notation. This x is between the -4 and the 9. When it's between, when it's both of them pointing in the same direction, x's are bigger than -4 or equal, and the numbers we want are also less than 9, not including the 9. This one is in two pieces, so we have to describe this one. The x's we want are from -infinity all the way up to -4. Never put a square bracket on the infinities. Up to 4. This one's an open circle, so we leave it a parenthesis. Union. And then this one starts at 1 and includes the 1, so we squarish type bracket, -1, including the -1, up to infinity. Now it says solve for x in this. So x minus 6x is 5x. Minus 5x. So to get rid of the -5, we have to divide both sides by -5. But when we divide on an inequality by a negative, or multiply by a negative on both sides, it flips the sign, and we get -2 divided by -5, which the negatives cancel, so it's 2/5 or 0.4. So x is less than or equal to less than or equal to 2/5 or less than or equal to 0.4. All right, so now we're supposed to figure out f of 2. So that would be 2, and for these x's, that'd be 2 squared, which is 4, plus 2 times 2 is 4, so that's 8. Now we're supposed to put -3 in. -3 squared is 9. 2 times negative 3 is minus 6. And we're supposed to find f of that. Well, 6 minus 9 is, 9 minus 6 is 3, so we're trying to find f of 3. So 3 squared is 9, plus 2 times 3 is 6, and we get 15. Now we're supposed to put a plus 2 in for the x's. So we get a plus 2 squared, because we're putting a plus 2 in for the x, plus 2 times, that's another x, so we got to put a plus 2. Now, a plus 2 squared is a plus 2 times a plus 2, plus 2 times a plus 2. This is a squared plus 2a plus 2a plus 4. And this is 2 times a, which is 2a. And 2 times 2 is plus 4. And now we can combine like terms. We got 1a squared. We have 2a's, 2a's, and 2a's, so that's plus 6a's. And we have 4 plus 4, which is 8. G of 7, if we put 7 there, 7 plus 2 is 9, square root of 9 is 3. K of negative 3, so if we go to negative 3, we get 1. What value makes this equal 8? So we got 3x minus 4 equaling 8. So we add 4. We get 3x equals 12. Divide by 3, and we get x equals 4. So if we put 4 in there, 3 times 4 is 12, minus 4 is 8. Just to check. All right, this says put negative 3 in for h. For the x in there, we use negative 3, and that goes to 0. So we're trying to find k of 0. And 0, k is negative 2. And f inverse. So this is y and this is x. Switch them. So we get x equals 3y minus 4 and solve for y. So we add 4. We divide by 3. And we get the inverse is equal to x plus 4 divided by 3. Now you could check yourself. Pick a number to put in for x, like 2. If I put 2 into that original problem, 2 times 3 is 6, minus 4 is 2. Okay, so if I put in 2, I get 2. If I put 2 in here, I should get back to 2. 2 plus 4 is 6, divided by 3 is 2. If that didn't convince you, try 1 or 5 or something else. Okay. Next page. So this is my f of x. And I'm supposed to figure out what happens to make this. And this is staying pretty much on the center, but it looks like it's flipped over vertically. So flipping it vertically is taking the same function and on the outside making it negative, and that flips it over. Now what happened here? Well, it looks like the same graph, except this was twice as high, this is twice as low. It's in the same position. It's not moved sideways. It's not stretched sideways. but it is stretched vertically. And so that's on the outside, and just like we think, so this is going to be 2 times whatever f of x look like. Making these points go twice as far away. This is down 1, going down twice as far, and going up. This was at a half. This goes up to 1, so that's it. F of 5. 5 is in this one, and so 5 plus 3 is 8. F of 0. 0's in this window, and so this doesn't depend on x, it's just 3. And f of negative 7. Negative 7 is less than or equal to negative 2. So we're supposed to take the negative 7 and square it. Well, negative 7 times negative 7 is positive 49. 27. The slope is the number times x. This is negative, so it's decreasing. This is positive, so it's increasing. And now we're supposed to find the equation of the line. So that's the change in the y over the change in the x. So the y goes from 3 to 5, so that's plus 2. And the x goes from 2 to negative 3, that's minus 5. So that's the slope, negative 2/5. The equation is y equals negative 2/5 times x plus something, the y-intercept. Now if we put 2 in here, 2 times negative 2/5 is negative 4/5. And we're supposed to add something to that to get, see, we're putting in the 2. We're supposed to get 3. Well, if we add 4/5 to both sides, we get this something has to be 3 plus 4/5, or 3 4/5. And I want to see the final equation, not just what the b is. If the town's population is 500 in 1950, and t is the number of years after 1950, it's sort of like we have a table here. 1950 is when t is 0, and the population is 500. In 2000, which is 50 years later, so t would be 50, the population is 2,500. So the slope, the population increased by 2,000 over 50 years. 50 goes, well, 10 goes in both of those, so 5 goes into 200 40 times. So I have a slope of 40. Change in y over change in x. Rise over run. So I have a slope of 40. So my model is going to be the population, depending on the t, is going to be 40 t plus the y-intercept. And since t is 0 here, the y-intercept is 500. We put 0 for t, 40 times 0 plus 500 makes the 500. So now we have a model, and we're supposed to predict for 2025. 2025 is 25 years later than this, so that'd be 75 that we'd put in for t. So we're going to do 40 times 75 plus 500, and the population is 3,500. That's the model's prediction. And the last page. So I'm supposed to graph this. So it's going to be hard to show it for you and do the graph at the same time. So I'm trying to draw it here. And we're going from 25 to 300. So I can go 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. 20, 40, 60, 80, 300. And I've used more than half. And this, the balance goes up to 210, so I can probably do the same units, or I might be able to use, see, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. If that's 100, 200, 10, I can do it that way. So I'm going to call this 100, 1, 2, 3, 4, 150, and 50, and 1, 2, 3, 4, 200. And I'll make my vertical line here. So now I can plot my points. So 25, 10, 20, 40 at 18. So this is 10, 20, 18, and I got to go to 25. So 20, 30, 40, 25 would be about there. 50, that's right in the middle. I got to be at a height of 34. 10, 20, 34 at 50. Then I got to do 80, 52, 80, 52, and 168, 100, 50, 68, 200, 144, 200, 100, 150, 140, 144, and 300, 210. 300, 200, 210. Now I got to draw a line through those. This is a nice long pencil, so I'll use it. And the dots are pretty much in a line, so I could maybe go just like that. Let's see how that looks. Yeah, I got a couple below. These are pretty close to on, so that's not a bad line for it. Looks like it's headed right for 0, 0 there. All right. Determine the slope in units. So the slope is the change in the y, so I got to pick 2 points. Let's use this one, which is 60, 40. Again, you're might have a little bit different line, so you might have a little different equation. And this one's pretty good. That's 280, 200. So my slope is 40 to 200. That's 160. centimeters more bounce height when I change from 60 to 280, which is 220. More drop height. Let's see. 10 goes into both of those, and that would make it 16 over 22, and 2 would go in those. It'd be 8/11ths. So the meaning of this is for every 11 centimeters, for every 11 centimeters added to the drop height, the ball bounces 8 centimeters more. What's the y-intercept? Well, my y-intercept looks like it's 0, 0. And so it means, well, in this case, it would make sense if this is the actual drop height. If dropped from 0 centimeters, it bounces up 0 centimeters. Okay, now we got to use technology. And I could do this on my calculator. I could switch to Desmos. I think you know how to do it on Desmos, so I'll just do it on the calculator. To do it on a calculator, for those of you who might want to know how to do this, Stat, Edit, and I get a bunch of lists. And I can go up on the list 1 and clear it. Go up on list 2's name and click clear, not delete. And then I can put in my data. 25, 50, 80, 100, 200, 300, then over, and I've got 18, 34, 52, 68, 144, and 210. And now they're in list, X's are in list 1 and Y's are in list 2, so I can go to second Y equals, and I can turn on plot number 1 by pressing enter and enter, and I can change which list they want it to be. I can find list numbers down here above the numbers, list 1, 2, 3, 4, 5, and 6. But it has the right lists. It's going to make little crosses. And I'm going to make sure I don't have any equations graphing. I got a bunch of them in here, so I'm going to clear that one, clear that one, clear that one, clear that one. And then I'm going to say zoom and stat. That means fit my statistics. And there it shows the plots. It's figured out its own scale, and it's plotted those points. Now let's figure out what the calculator thinks is a good equation. So we're going to go to Stat, Calculate the line, and I want it to be list 1, so I have to go down here and go second list 1, enter, and then I make this got to be list 2, so second 2, and I want to put the equation into y1, so vars y variables, function y1, enter and enter, and it's figured out the slope should be 0.71. A is the slope, x plus the y-intercept is negative 1.7. So it's predicting this is going to hit below the x-axis, but that's close to 0. And the y is the bounce height. So here's my mathematical model. I need to put the numbers in. And how well did it fit? Well, it said r squared is 0.998, which means a good fit. The line gets really close to all the dots. And if I push graph, you can see that it's really close to the same line that I had. In fact, what did I have for the slope? I had 8/11ths. They had 0.71. So I'm going to quit, and I'm going to go 8 divided by 11. And it said 0.72. 0.71, 0.72. That's pretty close. And I had 0 for y-intercept. The calculator's giving me negative 0.17. But anyway, that's the last problem.